Welcome to my lesson for control systems. This lesson is interactive. If you would like to follow along, there is a link to the game on the slide. This is a simulation designed and programmed by me, created to give you the ability to interact with and test a live control system. The goal of this control system is for the gray block to my right to be directly in front of you, the player. This chart is a live error time graph. For this control system, the error is the distance in between you and the block in arbitrary units. There are 4 inputs for you, the player, to test. Kp increases and decreases the proportional coefficient by 0.5, Ki increases and decreases the integral coefficient by 0.05, and Kd increases and decreases the derivative coefficient by 0.5. Finally, reset stops the control system and holds the block in place. Using this simulation, you can get a deeper understanding for how each coefficient affects the control system as a whole. Just to give you a few visual examples, I can set the control system to have a proportional coefficient of 0.5. We can see that the block quickly approaches the set point, us the player, and slows as it gets nearer. The block accelerates extremely fast at the start, but takes a while to reach us. This is the flaw of proportional control systems. They have difficulty with keeping forces balanced and reaching the goal without extremely high initial forces. If I were to set the Kp, the proportional coefficient, to an extremely high value, this would force real control systems with motors to snap their arms off at even the smallest of movements. Next, we can see how the block reacts to only an integral component. Strangely, the block simply oscillates from one end to the other. This is the flaw of using only integrals in a control system. On their own, they increase the output to a point where it overshoots the set point and repeats by oscillating back and forth infinitely. Finally, just derivative alone does nothing. Remember that derivative is the change in error, so without a change in error, derivative has no effect. True control systems use a combination of all values to reach the set point safely and quickly. Every control system is unique and has different ideal set points depending on the mass and inputs used. For this simulated control system, I've calculated the ideal outputs to be approximately a proportional output of 3, an integral output of 0.05, and a derivative output of 1.5. You can see how the block perfectly follows my character side to side whenever I move. This concludes my lesson on control systems. Thank you for taking the time to watch. Once again, if you'd like to try more, the simulation is linked on the slide. Thank you, and have a good day.